Hello, with this video I'm going to show you the process that I follow to analyze the data requested and give recommendations about it. At first, all I knew about the database was that it was data from 30 users as, for example, minute level results for physical activity, heart rate, and sleep monitoring. Also, that the individual reports were differentiated by session ID and date. And that's it. Nothing specific about what any of those 18 tables contain, let alone descriptions of each column of those tables. After downloading the 18 tables of the database, I uploaded them to Google Drive so I could use spreadsheets to view them. After uploading the tables and reading the headers, I understood a little more about what the information was about. For example, calories burned, intensity of activity, and steps taken per minute. I also realized that some tables had more than a million records, so I decided to work with SQL to manage this large amount of data. Knowing that I was going to work with MySQL, I changed the format of the datetime values to one that the tool could understand. I also rounded some values that had many decimal places that I was not going to use. For example, calories burned in 1 minute had 15 decimal places when 4 was more than enough. Having the files ready, I moved to my SQL workbench. There, I first created the database I was going to use. Then I created the tables that the database was going to contain and loaded them with the data from the files. For example, we can see on screen the queries for the creation of the daily calories table and the loading of data for that table. With this, I ended with 18 different tables that I was going to use for the analysis. After creating the tables, I checked for duplicates records within them. When a table had duplicates, I created another one without them. For example, on the screen are the queries to detect duplicates and create a new table without them for the minute sleep table. Out of 18 tables, 2 had duplicate records, so I created 2 new tables. With properly cleaned tables, I wanted to check if they really had 30 users, because if they didn't, I couldn't infer about the data because of the central limit theorem. This is how I did it, for example, with the daily activity table. What these queries told me was that out of 18 tables, 4 had less than 30 users, so I could not use them to infer information about all the population. They also showed me that the other 14 tables had 33 users each, but were those 30 users the same in all tables or did they change? To check this, I first created temporary tables with the different users for each of the 14 tables, so that the next query will be more efficient. This is how I did it, for example, for the daily activity table. Then I joined those temporary tables with an inner join using their user ID columns. This gave the intersection of all the users in all the tables. As this intersection had 33 values, the same number of users as all the other tables, the tables had the same users. Then I had another problem. There were tables that supposedly had the same values but in different formats, long data and wide data. So I wanted to check if these tables had the same values or not. To do this, I had to change the format of one table to the format of the other. I chose to change the wide data tables to long data tables because they are easier to use and analyze. To do this, I tried different ways to create a new table while organizing the data, all in the same query. That is, transpose the first row, then insert the transposition of the second row below it, and so on. But it was taking more time than I expected, so I resigned myself to that idea and decided to first create a table with the data and then, if necessary, organize it. So I used subqueries to insert the second column below the first one, then inserted the third, and so on. The queries to transform the wide data tables to long data tables are too long to show on screen, around 360 lines each. So on screen we can see the union of the first 3 columns of 60 of the minute calories wide table, in order to understand how the query works. Then I wanted to know if the long data tables had the same information than the transformed wide data tables. To do this, I first created temporary tables with values that did not exist in one of the tables but in the other did, and the values that varied between them. For example, on the screen is the query referring to the minute calorie narrow and minute calorie wide tables. I then counted the number of total rows in these tables, the number of values that did not exist in one table but did exist in the other for both tables, and the values where they were different. For example, on the screen is the query for the calories per minute tables. What happened with the three pairs of tables is that both tables had unique values, and the values that both had in common did not differ. Knowing that no table was complete, what I did next was to create new tables with all the values, adding to one table the ones it didn't have. On the screen we can see how I did it for the calories per minute pair of tables. So, the three pairs of tables that I had in the beginning ended up as three different tables. Then I wanted to check if these three tables had the same user ID date time combinations, because if so, I could join them into a single table. So I compared the size of the intersection to the size of the tables. It happens that those four sizes were the same. Being this the case, I created a temporary table with the information of the three tables. Then I remembered that there was another table with data about each minute, the minute METs narrow table. So I checked if the intersection of user ID datetime combinations of both tables had the same size. They didn't, but every combination in the METs table was in the complete table. Knowing this, I created a new table that included the previous two, the minute activity table. With this new table, all the tables with minute level activity were grouped into one. But this was not the case with the daily and hourly tables. Next, what I wanted to know was if the daily tables had the same data, because the daily activity table apparently had the same columns as the other three tables. So I created tables with the values that were unique to any of the tables and the ones that were different between them. For example, on the screen we can see the query that compares the daily activity and the daily calories tables. The three tables I created had no records. This means that the three tables were only duplicates of the data in the daily activity table. With this in mind, I decided to use only the daily activity table from those four tables. Having a minute and day table, I also thought was useful to have a table with the hourly values. First, I checked the size of the three tables and the size of the intersection. They all had the same size, meaning the same user datetime combinations. Then I created a new table showing the other three of them, hourly activity. After all of this, the data I was going to use wasn't organized in 18 different tables, but in 3. Having organized the data I was going to use, it was time to understand a little bit more the information in these tables. For this, and because I didn't have information about what the columns contained, I tried to understand them better. For this, I usually looked up the minimum and maximum values to know the ranges of the data and tried to interpret their names. For example, this is the query related to the calories consumed every minute. To check these columns, first I created a temporary table containing the addition of the calories burned every minute from the minute table by hour. Then I compared the values I calculated with the ones in the hourly table. From the 22,099 records, 22,092 were different. Knowing this result, I checked how much these values varied. What I found was that they differ in a range from minus 0.5007 to 0.5005. Looking at this result, I thought that the most part of the different values were because the temporary table I created didn't have the values rounded. So I checked again, but with rounded values from the temporary table. This time only 5 records out of 22,099 were different. Those should be the ones that were barely over than 0.5 or lower than minus 0.5. With this, I concluded that the values from the minute and hourly tables regarding the calories burned were consistent with one another. But I didn't know if they were consistent with the values in the daily table. To know if this was true, I first created a temporary table with the addition of the calories burned per minute from the minute table by day. Then I calculated the amount of records that had different values of the daily table compared to the ones I calculated. I also calculated the maximum and minimum differences. Out of 941 records, 936 had different values and the ranges of the differences were between minus 1880 and 2533 approximately, and this couldn't be because of rounding. Because of this, I concluded that the values from the minute and daily tables were inconsistent with one another. After checking the calories data, it was time for the steps taken. To do this, I first created a temporary table with the addition of the amount of steps taken every minute from the minute table by hour. Then I checked the results to the values of the hourly table and counted the amount of records that had different values. This amount was equal to 0, meaning that both tables were completely consistent between them. Then, to check if the minute data was also consistent with the daily data, I first created a temporary table with the addition of the steps taken per minute from the minute table by day. Then I counted the amount of times those values I calculated were different from the values of the daily table, and what was the minimum difference and also the maximum difference. Out of 942 rows, 162 had different values, around 70% of the rows, being the range of variation between minus 11,494 and 12,015. That range was really big, and that was why these two datasets were inconsistent between them. The minute, hour, and day tables had four similar columns: user ID, date, calories, and steps. These four columns were easy to understand, meaning identification, day and time, calories burned, and steps taken. But even if they had similar descriptions, I didn't know if the data contained in those columns were consistent between tables. So first, I started with the calories columns. Next in this analysis was the column named METs in the minute table. This column has a minimum value of 0 and a maximum value of 157, but I didn't know what a MET was, so I looked for it. According to Chate, Sidney, and Blumchen, in their work Metabolic Equivalents (METs) in exercise testing, exercise prescription, and evaluation of functional capacity, a MET is the number that represents how much oxygen is consumed compared to the oxygen consumed while in rest, per kilogram and per minute. For example, an activity that has 2 METs requires twice the resting metabolism. We can see some examples on the screen. One of those is playing basketball, and that activity has a MET value of 11.1. According to this study, the most intense activities never reach 20 METs, and this is why it is suspicious that the dataset has METs up to 157. It is also suspicious that there are values that are equal to 0, because that is not a possible MET value. I will continue on this subject later. Then it was time to understand the columns related to the intensity.